Before we start really machining in this episode, I would like to talk a minute about dyslexia and Asperger. Those of you who have one of those disorders might already have noticed that this guy has either both or one of those. As it is, I do have a mild case of Asperger and also, very mild dyslexia. So, first of all, my written English is and Finnish and German is really bad. And I also have some difficulties in reading those languages. This means that I need to experience by hand everything. I learn by feeling, by smelling, by touching and doing things. Well, that's how it is. And then this Asperger, which is considered as being a disorder that you should somehow cure. In its mild case, I believe I have seen quite many YouTubers who have this either dyslexia. One very famous YouTuber, you probably know who I'm talking about, has definitely has dyslexia, and I believe he's proud of it, and that's how you should be. So if you have those, take the benefit out of them. For example, normally when you have a dyslexia, you probably will also be seeking for perfection. You will be, you tolerate repetitive things quite well. And mild Asperger drives you to the same direction, so that, But, okay, that's enough of talking. If you wonder why I'm tolerating the continuous failures, how in earth can I do repetitive tasks here? That's the reason. I don't mind. It's in my head. And the only thing I sometimes find these machines to be really loud, even though they aren't. But I do have a solution for that one. This one helps. So let's go on with the dry plate. I can already tell you that I fail, but then I recover. Not in the way you might think. I will actually redo the whole thing. But let's see how it goes. It's not... Well, let's just see how it goes. Well, here is the going to be material. It has some... first of all, we need this mandrel. We need to push that away from there. It's glued in place, so I need to warm it up and then push it away. Not a big deal in that. I would like this to be exactly 23.5 millimeters, so I will need to peel off something from this mandrel. So that's one. And I need to make a hole here which is the same, and this seems to be, it's a hair under 23, so we might be able to pull it off from that. The next thing is that we need to get 20 millimeters. Well, the final dimension of thickness is 18, so to avoid having too much material, so I think 20 millimeters is more than enough. So I just now mark it here like 20 millimeters, and that is, I would like to have the fine pen this time. So I just mark here where the I think I need to make them with a thick one. Okay, for my angle grinder experience there outside, where we have complete darkness at the moment. Okay, now we have I did cut this, and this will go to the lathe after I extract that one. I will warm this up now to quite high temperature. I hope, well, quite high, it's quite relative, 300 maybe. Just like that. Okay, now it should be easy to push it away from there. Just lift it here and let's see what happens. Yeah, there you are. Now this is at the moment the wrong chuck for us, so I need to change it. I will swap to this collet chuck. Oh, that's sitting quite. So low gear helps in this case. Yeah. And these are not really tight. I have learned that they don't need to be like super tight. Yes, they need to be tight, but not super tight. There you are. Loose. Now, loose, 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 and loose. And then you just rotate the ring here and pull off your chuck. Like that. That's pretty nice. Store it away. And then we need this one. That needs to be really clean now. There shouldn't be any dirt inside here. And this also needs to be clean. This nut is used to pull it off from the spindle, and there is a notch here, there. Hopefully you can see it there. So I align it. We have a nut or a bolt here. I have tested this, and the most concentric is so that you have this notch adjusted with that one. You also, after that, you know which way when you put the collet inside there. So that's that. And then we need this guy, which is the drawbar. Goes to the back side of the machine. And then we can put this, oh yeah, here just to protect the threads. And then we need 20mm collet here. This is, and now as I know that this is the one, there is the screw, so I can align it directly. I don't need to search for that. And then I just tighten it. Oh yeah. Is this still warm? Yes, it is quite warm. This thing, well, I need to wait for it to cool down. This is too warm to be installed into there. no more too hot. It was really hot, and it's still quite hot, and it's quite tight into there. I think that's our place, and we are going to use quite high speed with this one, like that, I believe. Yeah, okay, let's first tighten it there, and then tailstock. Let's see that we have room. We should be about here. That's quite extensive stick out there, man. There we are. Okay, we have the full travel, I believe. Everything is tight, but the tailstock. And now, when adjusting tailstock again, it's a good idea to run the lathe while doing this. Let's see. Okay, we should be there now. Well, we should be ready now. I will first peel off 0.1 millimeters off from this, and after that I will measure it for taper. So let's see. The feed direction is correct, and now I'm touching. Yeah. And 0.1 millimeter. There you are. And there we go. Well, it cleaned all the way and it's really smooth. Well, wow. Let's see now. It should be 23.9 quite exactly at the moment. Well, it's not. It's 23.84. At this end, and that end then. Well, oh man, wait a minute, is this really true? So 500ths of a millimeter at least. No, it's more. So there 85, here 75. Yes, it's 1/10 of a millimeter taper. Well, that must be compensated. Just put this on so I can see it. Now it's 0, and now we need to move it 500ths this way, means needle should move that way. Okay. This is now at 0. I can move it from the cross slide here. So I put it into 0 here. So let's see now if I can move it easily here. Yeah. Not so easily, but I can. There is your 500ths. Now if I back up this a little bit, okay, there you are. 500ths. Okay, now, oh, nice surface. So let's measure it now. So this end is 23.68, and this end is it's 23.66, 200ths of a millimeter type taper. Well, that's okay by me. It's okay. Yeah. So let's go. Oh, that was a mistake. Half a millimeter too much. Man. Lucky me, I noticed it in time. Now it's okay. So we are 100ths of a millimeter oversized at this end, and we should be somewhat undersized this end. Here we are. And in the middle, oh yeah, let's see. In the middle we should be quite exactly. This is still oversized here. This is undersized here. Oversized. Well, here we are exactly. So it's if I make the hole exact, it stops here. I could actually, if I make it perfect, I could make it without glue. But that's not very good practice in this case because it's not easy. This is, oh man. You never get this kind of surface finish when you try it. But well, in this case we didn't really need that. But this is, it isn't shiny. But I can tell this, you cannot feel anything here. It's really, you cannot feel the surface. So now I just diffuse this setup and put back the 3-jaw chuck. Well, this is, lucky me, this is easy to do. Then this piece. And there is this side which I ground, and then we have this side which is probably flat. This is, it's quite bad dimension actually. I need to put it this way, and I don't like this at all. Oh well, I can see that the screw is still making contact there. Okay. Because I need to bore the center hole and okay. It's tight. Well, now I just bore this. Let's see. Now it should go there quite easily. This and it still didn't clean up. Man! That's bad actually, but it's let's say it's a clean up more than half, and that's already good. And this one should now go in without any. Well, it doesn't. It did not clean up. This is too tight. And we really have that 500 here. So, okay. It's still quite tight. How come it's tighter now? Man. Well, because this is the big end and this is the small end. Wow. This one doesn't go, that one goes, and it's well, I don't like this. And this should now be quite go quite easily to the hub. Yeah, okay. Well, this is a little bit tight, but I leave it there. That's okay now. So now the workpiece is moved from the lathe to here in the milling machine. And well, I have been first of all sweeping around this so that I got the height. Well, first I dialed this in so that it's concentric with the dividing head. And after that I was sweeping around so that also the spindle of this milling machine was concentric with the dividing head. And now I have moved the table down. Well, actually it has been moved down 39.46 millimeters. 48 millimeters actually. So, well, now we just make 32 cuts here. well, when you fail, just try again. A new workpiece. Well, and a different approach. I already know what went wrong with that end mill. When I was milling, it took the chips under on the lower side, and then it rolled with the chips over to the next slot, and it turned the workpiece into chuck. There were clear marks in the shaft, which showed that okay, it had been turning in there. So we need another approach. We don't want the mill to be plumed that way into the material. Well, what I will be using is a round-nosed end mill. I have an 8mm round-nosed end mill, which I will then use for this one. That should solve that problem, at least. But before I do that, because when I start using that, I will lose the setup here. So I will now drill and bore the holes, 6 holes here. here is well, a meshing test. And so far it looks really nice. It goes exactly as I planned it to go. So hopefully I don't block your view, but when this wiggles here inside, as you can see, it rotates. Well, yeah, this is so. Now this rotates, but when this is fixed in rotational means, so then it rotates the outer rim actually, and well, yeah, yeah, and it feels quite well. Maybe there are some chips. I don't know. I tried to clean it up, but yeah. Let's see if I can lift this up. Ah, yeah. There you are. Okay, so let's heat it up and push it away. Well, I have my butane torch. Trustworthy thing. Well, I try to give it a nice blue color as well. Let's see. Oh, it's hot. It's really hot. So let's see now. It should just drop away. Oh well. It's a little bit tight. Well, we need to. It didn't quite go, and it's really hot here. There you go. Well, let it cool down there. It's hot. So, let's talk about this cycloidic drive. Well, the principle is really nice. Execution, not. Well, this here is now my plan C. I already made one intermediate, very similar. You saw the video about that, and that failed. There were several reasons. The profile was the most difficult. But from that one I learned something. You can tilt the end mill. Now it is in a 30-degree angle, and this first of all makes the profile much nearer the needed one, and then it also makes it easier to manage so you don't need to take so small cuts. This profile, it shouldn't be like round, it should be elliptic somehow. I'm not sure what it really should look like, but this seems to be the most near one at the moment. Then again the diameter here is very critical. It should be exactly. There is if it's too small, it binds. If it's too large, it also binds. So and it doesn't bind when it's exactly the correct one. So okay, so now I'm just going to do this what I have been doing here. Well, the only problem with this setup is that chip evacuation doesn't work. You have to take care of that manually. Yeah. So therefore I have this. Yeah. So let's start with this one. Okay, now pressing out this part. So it's one of those easy operations to do. Well, it's good with Loctite, and well, yeah, I will warm up the... Okay, let's see now how this goes. This should go well. It was easier than I thought. Just touching the was enough. Well, because I didn't want the shaft on the top part, so it was smaller there. So now I just let this go down. that was it. Well, in the next episode I will be showing how those two things mesh together. The new ring which I have made, I have photos, I didn't show you how I made it, unfortunately, but it's a very good one and it works really nicely. And now the only thing is the drive plate, which has certain type of teeth form, which I also succeeded in making. It was a matter of fooling the dividing head a little bit, so I made it in 2 rounds. First normally, and the second one with 1 whole offset. So then it became quite near the desired form and it meshes perfectly. Now I only need to clean up the things and set the major diameter to a correct value so that it has room to wiggle there. Well, that will be in the next episode of Finno Brick Machining. Till then, bye!